Sometimes in math or science class, we maybe want to write really, really big or really, really small numbers. So say I wanted to talk about like how many feet it was to get from here to the sun. That number is going to be so large that if I'm writing it all out on paper, it's not going to be practical to write. Scientific notation is a method we use to write numbers like that are really giant, or like if it was really, really tiny, like how long is the human cell in feet or something like that. So, when you're doing scientific notation, you guys have probably seen this before, you want to only have one number in front of your decimal, and it's always going to be times 10 with some exponent on the 10. This is related to properties of exponents, which is why we cover it at this point in the year. So the first thing we're going to do is just take these scientific notation numbers and write them as a regular number, called standard form. And it's actually really not that bad to do. The exponent on the 10 tells you how many spots your decimal has to move. Notice how all of these numbers only have one number in front of the decimal. That's scientific notation. So positive 6, if you have a positive exponent, your number is going to get bigger. So you're going to take your decimal and move it 6 spots to the right to make your number bigger. Now you run out of numbers pretty quickly, so you have to add on zeros. I moved it 2 spots. I have to go 6. That means there's going to be 4 zeros on the end of this number. So what I'm going to have is 482 with 4 zeros on it, because altogether it's got to be 6 spots. I need 4 more for the zeros. And I'll put commas after every 3 numbers just to make it easier to tell what's what. So it's 4,820,000. On the second one, we have a negative exponent on our 10 right here. That's going to make our answer smaller. So what we're going to do is move our decimal to the left 5 spots. I'm able to move it over 1 spot, and I run out of digits. So again, I have to move it 5 spots altogether. I moved 1. There's going to be 4 zeros on the front of it. My decimal's going to be like over here. It's 0.0000. 4 extra spots, then 804. That would be how you'd write this number, just as a plain number. For my third problem here, again, same sort of thing. You can even pause the video and try these two for yourself. Same thing. 9 spots positive, so I have to move 9. I can get 3 right here. I need 6 more to get 9 altogether. So it's going to be 6 zeros on the end. So it's 6, 3, 9, 2, 1, 2, 3, 4, 5, 6 zeros to get 9 spots altogether. So I'd be looking at this number right here, 6,392,000,000 for my answer. And for the last one, negative 4, I move 1 spots. I have to move 3 more. I'll have 3 zeros on there, 0.00017. So that is how you write a number as just a regular digit. You pay attention to the exponent. It tells you how many spots to move the decimal. The other big thing I would ask you to do is to go backwards. So if I give you a number, you give the scientific notation. So what you do is you take the number, and you're only allowed to have one number in front of the decimal. So I'm going to write it, the decimal has to go right there. And basically I put all the other digits that I cared about. After this, they just start being 0, and I don't need those anymore. So I just did 1.402. So I would get that times 10, it has to be there. And I need to find the exponent on 10. But my decimal is now right here. I need to count and see how many decimal spots I would have to move to get back to my original number. So I'd have to go 1, 2, 3, 4, 5, 6, 7 spots to get back to where it's supposed to be, because originally the decimal is right there. So it's going to be 10 to the 7th power. On our second problem, it's the same sort of idea. You're only supposed to have one number in front of the decimal, and everything beyond there is just 0, so it doesn't matter anymore. So it's going to be 6.4. If my decimal is there, I need to move 1, 2, 3, 4, 5, 6 spots, but I'm making my answer smaller by doing that. It's a really tiny answer, so it's going to be 10 to the negative 6th. If I have 6.4 and I move the decimal 6 spots over, I get back to the orange number there. Last one on this section, same thing. Again, you'll write all the numbers that matter, that aren't 0 basically. If the numbers kept on going where they weren't 0, then that wouldn't be a great answer. You might have to cut it off somewhere. But if there's only a couple digits like that, you just copy as is. The rest is zeros, don't matter. Times 10, if my decimal was right here, I'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots to get back to my original number. So that would be how I'd write it in scientific notation. Final problem on the video. I didn't even write a problem here. Say we had like 2 to the 50th power, and we wanted to type that on the calculator. If you type that in the calculator, just to see what it equals here, 2 to the 50th power, your calculator is going to say something kind of strange. I'll leave it like right over here. It's going to say like 1.2 blah 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 E15. You see how it has that E on the end here. So I'm going to put like a squiggly equal sign because I'm in a round. It's 1.12. If I round, I guess it'd be 6 because 8 would bump this up. And it says E15 on the ends. That's what your calculator says. That is not what you write. That E does not mean error. That is your calculator's way of writing scientific notation. This is times 10. This is the exponents on the 10. So this means the same thing as this. This is what you would write down in your paper. This is what your calculator would say. So if you see that E, that does not mean error. That's your calculator's way of saying this is the exponent on the 10. So you would rewrite it like this. They mean the same thing. You have to move your decimal 15 spots. In other words, this is a really, really big answer.